Hi everyone, welcome to the online classes of Green Fusions. Today we are going to discuss the topic of strength of materials. So, strength of materials is also known as mechanics of materials. So, we need to know what strength of materials is. So, whenever we apply an external force to a body, suppose this is a body and we have applied an external force to it, we have applied force F, external force to it. So the tendency of the body will be to deform. The tendency of this body will be to sag. But this body consists of molecules, and these molecules are bind together by the cohesive force between them. So due to the cohesive force between the molecules of the body, this body will resist deformation. And the resistance that is being offered by the material of the body is known as strength of material. So strength of material basically deals with stress and strain. It is a very, very important topic, and you should have the knowledge of strength of material, because if you have the proper knowledge of strength of material, then only you will be able to design the safe structures. So for having the proper knowledge of strength of material, we should know the different types of forces that a body has to undergo. So before discussing the different types of forces, let's first of all discuss what a force is. What do you mean by force? So force is an influence that can change the condition of a body. It can bring a moving body to the condition of rest, as well as it can bring a body which is resting to a condition of movement. So it is an influence that can cause the change in the position of the body. So the force can be a pushing force as well as a pulling force. The force have magnitude as well as direction. That's why it is known as a vector quantity. So a vector quantity is a quantity which has magnitude as well as direction. The SI unit of force is Newton. So now we have discussed what a force is. Now we will move on to reaction. So the force and reaction both occur in a pair. Whenever there is a force, there will also be a reaction to it. Why it's so? Because as per the Newton's third law of motion, every action has an equal and opposite reaction. So whenever you apply a force to it, there will also be a reaction. So let us discuss it with the diagram. Here in this diagram, what you see, that a body of mass m is resting on a surface. So the body will have a weight. That weight will be equal to mg. And due to its weight, the body will experience a reaction. The reaction will be opposite to the direction of the force itself. So it will be opposite to the direction of the weight itself. And the magnitude of the reaction will be equal to the magnitude of the force. So the reaction R will be equal to mg. So now it's clear that force and reaction always occurs in pair. When there will be a force, there will also be a reaction to it. And the magnitude of the reaction will be equal to the force itself. And the direction of the reaction will be opposite to the force. So now we have discussed about the force and the reaction. We will move to the different types of forces. So first we will discuss the tensile force. So the tensile force, in the tensile force, you have to apply a pulling force. So whenever you apply a pulling force on a body, it will stretch the body and it will try to pull it apart. So suppose there is a body, you apply a pulling force F1 at one end and another pulling force F2 at another end. So what it will do, it will try to stretch the body. It will try to increase the length of the body. And what it will do, it will try to pull the body apart. It will try that the body should break in between. So in tensile force, you have to remember three things. First, it is a pulling force. Second thing, it will stretch the body. And third, it will try to pull the body apart. So now we have discussed the tensile force. We will move on to another force, that is compressive force. So in compressive force, you should remember that this is a pushing force. You have to apply a pushing force for compression. And the force will try to squeeze the body and it will try to compress it. So let's go back to the diagram. Here in this diagram, what you can see, you see that this is a body. You have applied a pushing force to it. This force is F1. Another force at the another end, F2. It's a pushing force. So what will happen? It will try to reduce the size of the body. It will try to squeeze the body. So in compressive force, you have to remember three things. First of all, it is a pushing force. You have to apply a pushing force for compression. Another thing is that if you apply a pushing force, it will try to squeeze the body. It will try to reduce the size of the body. And third, it will try to compress it. Now we have discussed about the compressive force. We will move on to shear force. So in shear force, the most important thing that you have to remember is the forces that we apply in shear are unaligned forces. Here you see in tensile force, the forces that we were applying were the pulling forces. These were the pulling forces. Suppose this is F1, this is F2. So these were the pulling forces. What forces we were applying? We were applying the pulling forces. And the line of action of these forces were aligned. This force and this force was in a line. Whereas in compressive force, we were applying the pushing force. Here also, the line of action of the forces were in a line. So these were aligned forces. In the compressive force and in the tensile force, the forces that we were applying were the aligned forces. But here in shear force, you see that when we are applying two different forces, this is F1, this is F2, the forces are not in a line. The line of action of this force is this one. The line of action of force F2 is this one. So these forces are not aligned forces. So these are unaligned forces. Here the force, in compressive force, we were applying the pushing force. In tensile force, we were applying the pulling force. But in shear force, you can either apply the pushing force or you can apply the pulling force. Here we have shown the forces at the as the pulling forces, but it can be pushing force also. Here another important thing is that the forces will try, one force will try to push the body in one direction, and another force will try to push the body in another direction. So the direction of the forces should be opposite. So the important things that you have to remember, first, that these forces, you have to apply the unaligned forces. And what will happen in the shear force, the forces will try that the one part of the body should slide over another part of the body. In original condition, the body will be like originally the body will be having a shape like this. You have applied two different forces, one in this direction, another in this direction, unaligned forces. Then what it will try? It will try that the body, one part of the body should slide over the another part of the body. This is known as shear force. So now you have understood about the shear force. We will move on to another force, that is bending. So in bending, you can see in this diagram, one force is being applied in this direction, another force is being applied in this direction, and here the body has bent. It has changed its shape, and it has caused, these forces has caused bending. So what you have to remember in bending? So the most important thing that you have to remember in bending, till now, what we have discussed in the shear force, in the tensile force, and in the compressive force, the forces that we were applying were all along the longitudinal axis of the element. Here you see that the force that we have applied was along the longitudinal axis of the element. But here in bending, the force, suppose this is the element, so this is the longitudinal axis of the element. So we apply force perpendicular to the longitudinal axis of the element. So this force is perpendicular to the longitudinal axis. And this force is also perpendicular to the longitudinal. This force is also perpendicular to the longitudinal. Whereas in shear force, you see that the forces that this was the element, so this was the axis of the element, and we were applying the force in the direction of the longitudinal axis of the element. Whereas in bending, we apply the forces that are perpendicular to the longitudinal axis of the element. So whenever an element is subjected to different forces which are perpendicular to the longitudinal axis of the element, then bending will occur. So now we have discussed about the bending. We will move on to another type of force, that is torsion. So what torsion is? In torsion, you have to remember that you have to apply torque. For torsion, you have to apply torque on the element. So what a torque is? Here you see you have an element and you have applied one force at one end of the element, another force at another end of the element. And the element has twisted due to the torsion. So this is called torsion, which occurs due to torsion. So in torsion, you have to remember one thing, that torsion, that it is that if you apply torque, then the element will twist, and this will be known as torsion. So what is a torque? Till now, the forces that you have applied were in a straight line. Here you can see in this figure, the forces that we have applied, these were in a straight line. This force was also in a straight line. This was also in a straight line. It was also in a straight line. It was also in a straight line. But in torsion, the force that you will apply will not in a straight line. You will apply a force in a circular direction. So I will give you an example of torque. Whenever you try to open the cap of a water bottle, you apply the force in a circular direction. So you apply a torque on the cap of the bottle, and then you are able to open the cap of the bottle. So that force is known as torque. So whenever you apply a torque, twisting of a body will occur and it will be known as torsion. So the unit of torsion is Pascal or Newton per meter square. So now we have discussed about torsion. We will move on to movement. So what a movement is? It is a turning force that you apply to an object at any distance from a fixed point. Suppose this is a fixed point and you are applying any force, you are applying a force F at a distance D from this fixed point, then it will be known as a moment. So a moment is a turning force that is being applied at a fixed distance from a fixed point. So the value of moment depends upon force and distance. So the unit of force is Newton. The unit of distance is meter. So the unit of moment is Newton meter. If we increase the value of D, so M depends upon F into D. So if we increase the value of D, the value of M will also increase. I will give you an example. If you have two screwdrivers of different lengths, one screwdriver is having a bigger length, another screwdriver is having a smaller length, and you try to open a screw, then you will see that if you are using a screwdriver with a bigger length, then you will be able to open the screw easily. Why it happens? Because in a bigger screwdriver, the value of D increases. So the value of D increases, so value of M also increases, and due to which you are able to unscrew you will able to open the screw easily. So this was the This was the definition of the movement. So now we will move on to another force, that is buckling. So here you might confuse between bending and buckling. So here I will make you clear that what is the difference between, here you will see that the element has also, here also the element will also bend. But the main difference in bending and buckling is, in bending, the force that we apply is perpendicular to the longitudinal axis of the element. Here, the force that we were applying were perpendicular to the longitudinal axis of the element in bending. But in buckling, the force that we are applying is along the axial direction. Here the force is not perpendicular to the axis of the longitudinal axis of the element. Here the force we have applied in axial direction and buckling has occurred. So buckling is usually observed in long columns. We will discuss about the long and short columns in our later lectures. So here buckling will usually occur in long columns during the earthquake. During the earthquake, buckling occurs in long column. In buckling, what happens? When you apply an axial load to an element, the element will buckle. So it is the change in shape or deformation of a structural component under load. It is known as buckling. And the load is axial load. That is the main difference between the bending and the buckling. So now we have discussed about all the different types of forces that a structure has to undergo. And I assume that you all have understood the concept of different types of forces very clearly. So that's all for today. Thank you so much.